Alright guys, here we go. Coach T back at it again with another fun-filled, action-packed, flipped geometry classroom video. Okay, so now we're moving out of Unit 2 and into Unit 3. And Unit 3 is gonna be logic. That means we're gonna start having to think and use our brains. Oh my goodness. Use your brain in math class? Coach T, what? That's crazy. Yep, guys, believe it or not, we're gonna start using our brain and thinking about things to get our answers because we're moving into logic. So without further ado, let's get started with this notes page. So I'm going to go to the screen sketch. So every time I exit a screen sketch, it's going to delete everything. So make sure you're writing down what you need to write down. But I'm doing this because it's a lot smoother to write. Okay, so here we go. So first of all, fill in your name. Okay. Conditional statement. That's the main idea here. Notes, a statement that can be written in the if-then form. That is a conditional statement. It is a statement that can be written in the if-then form, in the symbolic form, using symbols P arrow Q, and you read that like if P then Q. And we use the letter P because P stands for proposition. It's something that you're proposing. And then Q is just because it's, it's a nearby letter. P, Q, R, S, like that. So we're just using a nearby letter. But anyways, so then the blank is the phrase immediately following the word if. That's going to be hypothesis. The hypothesis, you might have learned this in a science class even. The hypothesis is the phrase immediately following the word if. And the conclusion is the phrase immediately following the word then. By the way, right here, or P implies, over here, implies Q. P implies Q. Okay, so let's go into the examples. Okay, so the first example, we're going to identify the hypothesis and conclusion of the following conditional statements. So number one, if you live in Nashville, then you live in Tennessee. Where is the hypothesis? Remember, the hypothesis is immediately following the word if. So here's if, and immediately following is you live in Nashville. So we're going to write that the hypothesis is you live in Nashville. And then the conclusion, that's the phrase that immediately follows then. So we've got you live in Tennessee. So there we go. That's it. So now we're going to be writing conditional statements. So we're going to write our following statements in the if-then form. So they give you a sentence and you're going to change it to a conditional statement. So if P then Q, or the if-then form. So let's look at here. An obtuse angle has a measure greater than 90 degrees. So let's look at the first section they gave us. They said an obtuse angle. So let's write it. We're going to write it like this. If an angle is obtuse, and then what do we need? We need then. Then it has a measure greater than 90 degrees. Greater than 90 degrees. Okay, so if an angle is obtuse, then it has a measure greater than 90 degrees. We took the sentence that they gave us and changed it to be a conditional statement. So let's look at number 2. It says all numbers divisible by 4 are also divisible by 2. So the first part is all numbers are divisible by 4. So if a number is divisible by 4, then let's take the rest. It is also divisible by 2. And that's it. So you guys try 6 through 8 right here, and we're gonna go on to the next part. Here we go. Counterexample. A counterexample is, let's get the definition down, guys and gals. A counterexample is an example that shows a conjecture. That means like idea. Conjecture is like something you're proposing. It's an idea. Is false. I don't know why I put a comma there. That's weird. A conjecture is false. You're pretty much giving an example that counters the idea, showing that it's false. So let's look at these examples. Determine whether the conjecture, that's the sentence or idea they're giving you, is true or false. If it's false, provide a counterexample. So first we're going to see if it's true or false. So the sum of any two consecutive integers is always odd. So if you're adding two numbers in a row, it's always odd. So let's just think about it. Let's go 0 plus 1, that's 1. Is that odd? Yes. Okay, 1 plus 2, that's 3. Is 3 odd? Yes. Okay, 2 plus 3, that's 5. Is 5 odd? Yes. Negative 3 plus negative 2, that's negative 5. Is that odd? Yes. So it seems that it's always odd. So this one's going to be true. And there is a way to actually prove it, but for now we're just going to put true. All right, let's do number 2 together. The product of two numbers is always larger than either number. So they're saying that if you multiply two numbers together, it's always larger than both of those numbers. So that's going to be, can you think of a counterexample? Take a second, think about it. That is going to be false. Because what about this? Check this out. If I go with negative 8 times 4, that equals negative 32. Is negative 32 greater than 4? No. Is negative 32 greater than negative 8? No. So, as we can see, there's my counterexample. Negative 8 times 4 equals negative 32. So then down here at the very bottom, write your own conjecture. Write an idea, make up an idea. And then later in class, the following day, we're going to, give it to our partner, and they're going to see if it's true or not and give a counterexample if what you wrote isn't true. But that's the end of this video, guys. And so until next time, see you later. Peace.